Hi, today I'm taking a class for polynomial and factorization for class 9th. So first I'll give you the definition of a polynomial. Any algebraic expression, I can say ax square or 2ax plus by or 2x plus 2x square plus 5x minus 3. These are all called as polynomials until and unless the power is positive integers, and that's all. Positive integers, power should be of positive integers, then only we can call it as a polynomial. So if I say like this, x plus 1 by x, so this is not a polynomial because the power of this x will be written as x to the power of minus 1 according to our indices laws. That is a to the power of minus 1 is equals to 1 by a. So, or even if you have 2 root x plus 5, also this is not a polynomial. Even I can say the power of the variable should be positive integers. See, I am forcing on positive integers. It means the power should not be fraction, the power should not be negative integers, only positive integers. So those algebraic expressions whose powers are positive integers, they are called as polynomials. Now the polynomial in one variable, generally if I want to say polynomial in one variable, I can say general form ax plus b, where a comma b belongs to real numbers and a should not be equals to 0. For example, 2x plus 5. The power here, the power of x is 1. Okay, so this is called as a polynomial in one variable. I can even have sorry. So polynomial in one variable, this is the variable x. If I say 2x plus 3y, this is a polynomial in two variable. But when I say 5x cube, this is a polynomial in one variable. I'm not referring about the power. Okay, so whenever we have a one variable, then that polynomial is called as a polynomial in one variable. Now we will see the degree of a polynomial. So the highest power of the variables in a polynomial is called the degree of the polynomial. So now here we have, for example, 2x square plus 9x plus 5. So this is the highest power here. The power of x is 2 and the power of x is 1. So this is the highest power. So degree of a polynomial is 2. Okay, so whenever I have a polynomial in two variables, in a term, if I am having two variables, for example 2xy plus 5x square plus y to the power of cube, then the degree will be taken as the power of these two. It means degree is equals to 2 plus 3, which is equals to 5. So now next we'll see now we'll see the first exercise, that is 2.1 for Telangana State syllabus for class 9th. Find the degree of each of the polynomial given below. Now the first problem is given to you as find the degree. So now here first problem is given as exercise 2.1. I have to find out the degree, x to the power of 5 minus x to the power of 4 plus 3. So the highest power, that is 5, is called as the degree of polynomial. Okay, second one I'm taking separately. I'll take like this. See, this is the sixth problem you have in your exercise, that is 5t minus root 3. So now here the power of t is 1, so 1 is equals to degree of polynomial. Okay, now second problem is, which of the following expressions are polynomials in one variable and which are not? Give reason. So first one is given to you as second question, polynomial in one variable, 3x square minus 2x plus 5. So now here you see we have variable x only. So this is a polynomial in one variable. I can see this as one variable, first one. Second one, it is given as, if I see this one, sorry, I'm taking third one. Third one is given as p square minus 3q plus, sorry, 3p plus q. Now here you got two variables, p and q. So this is a polynomial in two variables, p and q. So it is not a polynomial in one variable. Polynomial in two variable. Okay, so it is not a polynomial in one variable. Like you have y plus 2 by y. So here I can say that it is not a polynomial. Y means, see here, y plus 2 into 1 by y can be written as y to the power of minus 1. As I already told you that the power of a variable should not be negative integer. It should be only positive integers, no fractions as well. So this is not a polynomial. Now next problem we'll see, we have one more. See here, 5, next question you have 5 root x plus 5 root y. Root x, sorry, here it is x root 5. See here, 5 root x can be written as x to the power of 1 by 2 plus x into root 5. Now the variable has got a power as a fraction, so it is not a polynomial. So now the third problem is asking, write the coefficients of x cube in each of the following. So for the coefficient, third problem, for the coefficient of x cube, third problem, he is asking for coefficient of x cube. First one is given as x cube plus x plus 1. Solution, here the coefficient is 1, so coefficient of x cube is equals to 1. Generally, whenever we don't have any coefficient for the variable, we take as 1 as a coefficient of a variable. So the coefficient of x cube is 1 here. Now next one you have, I'll take third one. Third one is given to you as root 2 x to the power of 3 plus 5. So here the coefficient is coefficient of x cube is equals to root 2. Okay, now we have some more. I'll take this sixth one, minus 2 by 3 x cube. So here the coefficient is of x cube is equals to minus 2 by 3. And seventh one is given as 2x square plus 5. Since here I'll take in this way, 0 into x cube plus 2x square plus 5. So we don't have x cube, so I'm taking 0 into x cube. 0 into the number is 0, so coefficient of x cube is equals to 0. So I hope you understood how to find out the coefficient. When a variable is multiplied by any number, any other numerical number or any other variable, then that gives the coefficient of the variable which is asked. Okay, classify the following as a linear, quadratic and cubic polynomial. So now we will see. I'll give you the general form of the linear, quadratic and cubic polynomial. Linear polynomial. So general form is ax plus b. Okay, this is called as a linear polynomial. I can even write this as 2x minus 1. Examples I'm giving you. Or I can say 1 by 2a plus 3. Or even I can say 2x. This is also a linear polynomial. Okay, or root 2x minus 1 by 2. This is also a linear polynomial. Root 2 is only for x. Now next you have quadratic polynomial. So the general form is written as ax square plus bx plus c. This is called as a quadratic polynomial. So I can say 2x square plus 5x minus 7, or 1 by 2x square plus 2. This is also a quadratic polynomial. Or 5x square, also a quadratic polynomial. 3a square plus b plus, sorry, not b, plus 1 plus 2a. These are all the different types of quadratic polynomial. So we have, this is the first one, this is the second one. Then next one we can say cubic polynomial. So one thing I forgot to tell you, in linear polynomial, the degree of the polynomial will be 1. The degree of the variable should be 1. Then only we can say that it is a linear polynomial. In the second, quadratic polynomial, the degree of the polynomial will be 2. Degree means highest power of the variable will be 2. Then only we call it as a quadratic polynomial. So I hope linear polynomial, if the variable has got the degree as 1, that is the highest power as 1, then it is called as a linear polynomial. And for the quadratic polynomial, if the highest power of the variable in a polynomial is 2, then it is called as a quadratic polynomial. Cubic polynomial, I will give you the general form. It is as ax cube plus bx square plus cx plus d. Okay, this is plus d. So a should not be equals to 0. Here a should not be equals to 0. Here also a should not be equals to 0. Okay, now any polynomial with the highest power as 3, that is the degree of the polynomial is 3, then it is called as a cubic polynomial. Okay, so this is what you have to find out from your question 3, which is a linear and which is a quadratic and cubic polynomial. I hope with this you can understand easily how to find out the polynomials, which type of polynomials are they. So for question number 4, the first one is given as 5x square plus x minus 7. Okay, so the degree of the polynomial is 2, so it is a quadratic polynomial. Second one, I have x minus x cube. The degree of the polynomial here is 3, so it is a cubic polynomial. Third one, I have, we'll see the fourth one. Fourth one is given as x minus 1. The power is 1 here, so the degree of the polynomial is 1, it means it is a linear polynomial. Okay, and 3p, fifth one, 3p, degree of the variable is 1, so degree of the polynomial is 1, the power of the variable, highest power is 1, so it is also a linear polynomial. Okay, now even for sixth one, pi r square, r is the variable, so the highest power is 2, so this is the degree of the polynomial, so it is a quadratic polynomial. Okay, so now next there are some true or false. So we will go for the zero of the polynomial. What do you mean by the zero of the polynomial? See, whenever we are substituting any value for a polynomial and for because of that value we are getting 0, then that value is called as the zero of the polynomial. For example, if I have p of x is equals to x square minus x, plus x minus 2. If I am taking x is equals to 1, so I can say p of 1 is equals to 1 square plus 1 minus 2, 1 plus 1 minus 2, 1 plus 1 is equals to 2 minus 2, which is equals to 0. Therefore 1 is called as 0 of the polynomial, that is p of x. Okay, or when we are substituting and we are not getting 0 any value, then p of 1 is equals to 4 is the value of the polynomial. Now, so we can say in general that the 0 of a polynomial p of x is the value of x for which p of x is equals to 0. So I can even say that p of 1 is called as the 0 of the polynomial, or 0 for p of x, 0 of the polynomial p of x, the value of x, it is the value of x, see this is the value of x for which p of x is equals to 0. Now we will see how to find out a 0 of a linear polynomial. See, if I have p of x, this is a polynomial, is equals to ax plus b. I'll suppose let p of x is equals to 0. Now it means ax plus b is equals to 0. So ax is equals to b को मैं ट्रांसपोज कर रहा हूँ, ट्रांसपोजिंग b, so it will be minus b. X is equals to minus b by a. So whenever I substitute x as minus b by a, then p of x will become 0. So x is equals to minus b by a is the only 0 of the polynomial, of the linear polynomial. So you can see in this way, see x is equals to minus b. So p of minus b by a is equals to a into minus b by a plus b. So a one times goes, so I'm getting minus b plus b, which is equals to 0. So I can say x is equals to minus b by a is the only 0 of p of x, which is equals to ax plus b. So a linear polynomial in one variable has only one 0. You have to keep this in mind, that a linear polynomial in one variable has only one 0. So we cannot get more than 1 0 for a linear polynomial. For a quadratic polynomial, for example, if I see See, I have x square minus 3x plus 2. This is p of x. So I want to find out the zero of the polynomial. So now I'll see x is equals to 2 and x is equals to 1. What happens? P of 2 is equals to 2 square minus 3 into 2. I'm placing 2 in place of x plus 2, substituting 2 in place of x. So I'll get 4 minus 6 plus 2. This and this both are with plus sign, 6 minus 6, which is equals to 0. Now p of 1, that is 1 square minus 3 into 1 plus 2. So there is 1 minus 3 plus 2. 1 plus 2 is equals to 3 minus 3, which is equals to 0. So now see, so with this we can say that a quadratic polynomial, the given polynomial is a quadratic polynomial because the degree of the polynomial is 2. So with this I can say that the quadratic polynomial has 2 zeros. Okay, 2 and 1. So I can say that 2 and 1 are both the zeros of a quadratic polynomial. Now we'll start with exercise 2.2. Exercise 2.2. Find the value of polynomial 4x square minus 5x plus 3 when x is equals to 0. First one, p of x is given to me as 4x square minus 5x plus 3 when x is equals to 0. So p of 0 is equals to 4 into 0 square minus 5 into 0 plus 3. So 0 into any number is 0 minus 0 plus 3. So the answer is 3. So p of 0 when x is equals to 0, p of x is equals to 3. So second one is telling x is equals to minus 1. So p of minus 1 is equals to 4 into minus 1 whole square minus 5 into minus 1 plus 3. 4 into minus 1 whole square will gives me, see, minus 1 whole square is equals to minus 1 into minus 1. Minus into minus is plus, 1 into 1 is 1. So I'll get 1. So 4 into 1 minus into minus plus, 5 into 1 is 5 plus 3. So 4 ones are 4 plus 5 plus 3, which is equals to 9, 10, 12. So when x is equals to minus 1, p of x is equals to 12. Now we will see what happens when x is equals to 1 by 2. What will be the value of p of x when x is equals to 1 by 2. X is equals to 1 by 2. So we'll say p of 1 by 2 is equals to 4 into 1 by 2 whole square minus 5 into 1 by 2 plus 3. So this gives me 4 into 1 by 2 into 1 by 2 will be 1 by 4 minus 5 ones are 5 by 2 plus 3. So 4 1 times, 4 1 times. So 1 minus 5 by 2 plus 3. 1 and 3 both are positive numbers. 1 plus 3 will give me 4 minus 5 by 2. So cross multiply and see the LCM. 2 4s are 8 minus 1 5s are 5 by 2 1s are 2. 8 minus 5 is 3 by 2. This is the answer. So when x is equals to 1 by 2, p of x will be 3 by 2. Find p of O, p of 1, p of 2 for each of the following. So second question is given as p of 0. P of x is given to you as p of x is equals to x square minus x plus 1. So p of 0, which is equals to 0 square minus 0 plus 1. So the answer will be 1 because 0 0 is 0 only. Next, p of z is equals to z cube. So now I'll see p of 1, p of 0, that is 0 cube, which is equals to 0. P of 1, that is 1 cube, which is equals to 1. P of 2, that is 2 cube, that is equals to 2 into 2 into 2, which is equals to 8. Now we'll see one more. P of t is equals to t minus 1 into t plus 1. What happens with P of 0? That is 0 minus 1 into 0 plus 1, that is minus 1 into plus 1, which is equals to minus 1. So P of 1, that is 1 minus 1 into 1 plus 1. 1 minus 1 is 0 into 2, which is equals to 0. P of 2, that is 2 minus 1 into 2 plus 1, that is 1 into 3, which is equals to 3. I'm just substituting t 2 in place of t. So the question is here, see, P of t, P of 2, 2 minus 1 into 2 plus 1, P of 1, 1 minus 1 into 1 plus 1. So you can see that see the result. 1 minus 1 is 0, 1 plus 1 is 2. So 0 into any number is 0. So P of 2, 2 minus 1, 2 minus 1 into 2 plus 1, 2 plus 1. 2 minus 1 is 1, 2 plus 1 is 3, 1 into 3 is 3. Okay, now the next problem I have is, there is a third problem which is asking, verify whether the values of, third problem, verify the values of x given in each case are zeros of the polynomial or not. So first one is given as P of x is equals to 2x plus 1. So I have to see when x is equals to minus 1 by 2. So P of minus 1 by 2, that is equals to 2 into minus 1 by 2 plus 1. 2 1 times, 2 1 times. So minus 1 plus 1, which is equals to 0. So I can say therefore minus 1 by 2 is 0 of P of x. Okay. Now the second problem, second bit is P of x is equals to 5x minus pi. So you have to find out x is equals to 3 by 2. So P of 3 by 2 is equals to 5 into 3 by 2 minus pi. So 5 3 is 15 by 2 minus pi. Therefore 3 by 2 is not a 0 of P of x. So now we'll see some more problems from this. I'll see here fourth bit. It is given as P of x is equals to x minus 1 into x plus 2. Now I'll take x is equals to minus 1 and x is equals to minus 2. First P of minus 1, which is equals to, put minus 1 in place, substitute minus 1 in place of x, minus 1 minus 1 minus 1 plus 2. So this gives me minus 1 is minus 2, minus 1 plus 2. Opposite sign we have to subtract, 2 is greater, so I'll get 1 with plus sign. So when we multiply minus into plus is minus, 2 1s are 2. So minus 1 is not a 0 of the polynomial. We'll see what happens with minus 2. P of minus 2, that is equals to x, in place of x I am subtracting minus 2 minus 1, again minus 2 plus 1. So minus 2 plus 2. So this will be minus 3, but minus 2 plus 2 is 0. So 0 into any number is 0. So I can say that minus 2 is the 0 of the polynomial, but minus 1 is not the 0 of the polynomial. Now one more problem is given, we'll solve that also. And it is this. F of x is equals to 3x square minus 1, and x is equals to minus 1 by root 3 and 2 by root 3. First I'll take x is equals to minus 1 by root 3. So that is 3 into minus 1 by root 3 whole square minus 1. So 3 into minus whole square means plus 1 as it is. Root 3 whole square becomes 3. Root 3 into root 3 is root 9. Square root of 9 is 3 minus 1. 3 one times, 3 one time. So this gives me 1 minus 1, which is equals to 0. Therefore I can say minus 1 by root 3 is 0 of p of x. Okay, so now next we will see 2 by 3, p of 2 by 3. P of 2 by root 3, which is equals to 3 into 2 by root 3 whole square minus 1. So this gives me 3 into 2 whole square, 4 root 3 whole square means 3 minus 1. 3 one times, 3 one time. So I'm getting 4 minus 1, which is equals to 3. So 2 by root 3 is not a 0 of the polynomial, but minus 1 by root 3 is the 0 of the polynomial. Now he's asking find the 0 of the polynomial in each case. Fourth problem, we will be solving the fourth problem. First bit, f of x is equals to x plus 2. So I'll suppose let f of x is equals to 0. That implies x plus 2 is equals to 0. That implies transpose 2, x is equals to minus 2. Therefore minus 2 is 0 of p of x. So whenever you substitute, for example, p of minus 2, that is equals to minus 2 plus 2, which is equals to 0. Got it? So this is how you can see the 0 of the polynomial. So next you have, I'll take the fourth bit. Fourth bit is given to you as f of x is equals to 2x minus 3. So let f of x is equals to 0. So 2x minus 3 is equals to 0, because f of x is 2x minus 3. So in place of f of x I am writing 2x minus 3 is equals to 0. 2x is equals to, I am transposing 3, so it will be plus 3. X is equals to 3 by 2. So I can say 3 by 2 is the 0 of the polynomial. We'll verify this. F of 3 by 2, which will be equals to, substitute in this one, 2 into 3 by 2 minus 3. 2 one times, 2 one times. So 3 minus 3 is 0. So this is how we find out the zeros of the polynomial. Now the fifth problem. Fifth problem is given as if 2 is the 0 of the polynomial, then find the value of a. Polynomial is given as p of x is equals to 2x square minus 3x plus 7a. I have to find the value of a. So p of 2 is equals to 2 into 2 square minus 3x plus 7a. So 2 square means 4. 2 into 4 minus 3 into 2 is 6 plus 7a. So 2 4s are 8 minus 6 plus 7a. 8 minus 6 is 2 plus 7a. Given p of 2 is equals to 0, that implies 2 plus 7a is equals to 0. That implies transpose 2, 7a is equals to minus 2. That implies a is equals to minus 2 by 7. So this is the value of a. See, what we did is in place of x I wrote 2 square minus 3 into 2 plus 7a. 2 square means 4, 2 into 4 minus 3 into 2, this is 2. 3 into 2 is 6 plus 7a. 2 4 the 8 minus 6 plus 7a. 8 minus 6 will give me 2 plus 7a. Given P of 2 is equals to 0, since it is the 0 of the polynomial cell. So 2 plus 7a is equals to 0. Transpose 2, it will be minus 2. A is equals to minus 2 by 7. So this is what we have done. Now the next sixth problem is given as, if 0 and 1 are the zeros of the polynomial, find the value of a and b. 0, 1 are sixth problem. 0, 1 are zeros of p of x, and f of x is given as 2x cube minus 3x square plus ax plus b. So first I'll take f of 0. F of 0 is equals to 2 into 0 cube minus 3 into 0 square plus a into 0 plus b. So this gives me 0 minus 0 plus 0 plus b. Since f of 0 is equals to 0, that implies b is equals to 0, since f of 0 is b, which is equals to b. So b is equals to 0. Now f of x, write down 2x cube minus 3x square plus ax plus b. So f of 1 is equals to 2 into 1 cube minus 3 into 1 square plus a into 1 plus b. So this gives me 1 cube means 1 only. So 2 into 1 is 2 minus 3 plus a plus b. So this gives me minus 1 plus a plus b. Since f of 1 is equals to 0, that implies minus 1 plus a plus b is equals to 0. Okay, that implies a plus b is equals to 1. I am transposing minus 1, so it will be plus 1. That implies a plus 0 is equals to 1. Since b is equals to 0, that implies a is equals to 1. This is the final answer of 6th. So we have completed 2 exercises. So in the next class we'll solve the other exercise as well. Thank you. Hope you like this session. So take care and bye.